Hi everyone, welcome back to another Pre-Calculus 12 video. Today we're going to be doing 6.2 trigonometric functions of acute angles. And I reviewed with you last day that acute angles, just to remind you, is just what it sounds like. It's a cute little angle, meaning it's between 0 degrees and 90 degrees, and or just to build in some review, if we were talking about radians, it would be between 0 and pi over 2. So it's good to be able to go back and forth between degrees and radians and to become familiar with it. So there's a little bit of review for you. I'm not playing the music in the background today because I have noticed that it's been just going really loud on its own. So I'll continue to work on trying to figure that out. But for today, sorry, no calming music in the background. You'll have to play your own. And let's start off with some review of Sohcahtoa. So I'll do this vertically here. Sohcahtoa. And I'm going to group them together to just remind you that this would go together because it's the symbol or acronym for sine, which is equal to opposite over hypotenuse. So remember that this is when we're dealing with a 90-degree angle or a right angle triangle. We can use Sohcahtoa to help us to figure out any missing angles or missing sides. And the next one would be for cosine, which we know is adjacent, the adjacent side, over the hypotenuse. And so I will group those together. And the last one we know is tangent, which is opposite over the adjacent side. So these three go together, just to remind you where sine, cosine, and tangent are the three ratios that we are interested in. Okay, but what I want to show you is that they actually have some reciprocal relationships that go along with this. So if we're looking at this first one, sine goes with cosecant, which is abbreviated like this, cosecant theta, and that would be equal to basically just the reverse of these. So hypotenuse over opposite. I'm going to just cut those off because I know that you know what they mean. Hypotenuse over opposite, it's just the same thing as what we use with sine. Okay, so the reciprocal that goes with this would be called secant. So secant goes with cosine and cosecant goes with sine. So it's actually the opposite of what you would intuitively think. And we would abbreviate that this way. Secant theta is how we would write it. And that's the opposite of that. So it'd be hypotenuse over adjacent. And the last one, for tangent, we have something called cotangent. So this one's a little bit easier to remember. We would abbreviate that with COT, so cotan theta, equals, and it's the opposite, the reverse, I should say, of these two, which is adjacent over opposite. So we're taking some old information, which is our Sohcahtoa knowledge, and we're learning some new stuff that goes along with it. And we'll take a look at what to do with those in just a moment. And I'm first going to go through something called a reference angle. A reference angle is always an acute angle. So it is less than 90 degrees, or less than pi over 2, if that's what we're looking at. And it's formed by the terminal side of the given angle and the x-axis. This is really going to become clear when I show you an actual example. So let's dive right into that. Let's take a look at what this might look like. If, for example, we have, let's say, this angle here, and I tell you that that angle is 40 degrees. So it says formed by the terminal side of the given angle, so terminal side of the given angle, so that would be this, and the x-axis, and it's always the positive, well, in this case it's the positive x-axis, but I'll show you some examples where it's not just the positive x-axis, but in this case it would be, so where all the x values are positive. So that would be my reference angle. So that's a pretty straightforward example where it already is an acute angle and it's easy for us to be able to spot it out or to see it. So let's take a look at one that's maybe not quite so straightforward. So let's say this time the terminal side of the given angle, so I'm going to draw it like this. And if we are looking for, so read what this says. It's always an acute angle. So let me tell you this. This whole thing is our angle, and it's 120 degrees. Okay, but if I read the reference angle, it says it's always an acute angle, so this 120 degrees doesn't make the cut. If I read on, it says it's formed by the terminal side of the given angle, so that's this teal blue side, and the x-axis. So in this case, I'm going to take the negative x-axis. So when I go to look for my reference angle, I'm going to put a theta in here. My theta's kind of messed up because the pen's too thick, but there's my theta, and that is actually going to be my reference angle. So let me do the work down below here. So I would, if I want to know what this theta is, actually let me fix this, let me make it less thick. So if I want to know what that is, down here, I'm going to say, okay, it's 180 degrees to get all the way to a straight angle. And I'm going to subtract from it the 120 degrees that helped me to form where the terminal arm goes. And when I subtract those, what I'm left with is 60 degrees. So 60 degrees is my reference angle in this case. I'm going to put a box around that because that's our answer in this scenario. So I'm going to fix that. It's bothering me. That must be 60 degrees. That's what I take as my reference angle. Okay, so then I feel like you've probably kind of gotten the hang of this or can see what's going on here, but let's practice another one. Let's say I give you one that's all the way down here. Oh gosh, that's the wrong color. Let's say we do it with that. And when we go to there, we know that that whole angle is 240 degrees. So again, it doesn't make the cut. This is not an acute angle, so I need to do my work to figure out what the reference angle would be. So I look for the closest x-axis, which happens to be the negative side of it, and I'm looking for the angle that's formed from the closest x-axis down to my terminal arm. So I want to know how much that is. So this time maybe I'm going to use my math skills in a reversed order to try to figure out what this is. This time I'm thinking, okay, if going from here to here is 180 degrees, and I have all the way to 240, I'm going to flip this and say 240 degrees minus the 180 degrees that's there. So basically, just trying to find the difference between these two. So I've done 240 minus 180, and this also just happens to be 60 degrees for my reference angle, and I'm going to put a box around there to say that's my reference angle. And I'm guessing you probably don't even need this last example, but we're going to very quickly run through it just to show you how it would look in, let's say, the last quadrant. So let's say I go all the way around and I have an angle around right here. So when I go all the way around like that, oh, I think I have to do that in white. When I go all the way around like this, I know it's 315 degrees. Yeah, but that's not my reference angle. So again, I keep the same pattern as what I've been doing, and I'm going to zoom in to show you. If I want it from the terminal side of the given angle to the x-axis, this time I use the positive x-axis. So basically choose the closest x-axis that will allow you to give an acute angle. So that's going to be my theta, or my reference angle. And so the smartest way for me to get it this time is, while I know a full rotation would be 360 degrees, I'm going to subtract the 315 degrees from it. So I get that my reference angle must be 45 degrees when I subtract those two out. Okay, so you get the idea and the hang of how we would come up with that based on this. I hope that that was helpful. And look how bright and beautiful and colorful it is. I love this black background. Gary, thank you very much for teaching me how to do this. And so let's move on to a new concept. Well, kind of, but not really. So let's look at our trigonometric ratios. This looks like a Halloween scary font. Let's fix this. What on earth happened there? That's better. Trigonometric ratios, which you already know, that's like Sohcahtoa, but we're going to do it on this pretend unit circle. I guess it's not really pretend, but so there's some terminal arm. I'm going to put some point there, and I'm going to call that point xy. And then I'm going to, I guess this is what I mean by pretend. We're going to pretend that it goes all the way around in a beautiful, perfect circle, even though it's kind of lopsided. And then this is going to be our theta, the central angle that's in the middle. We know that this would form the radius if we're putting it in a circle. So if we're looking at this point xy, then sine theta would be equal to y over r. Because we know that if this is theta, it would be opposite, which would be this y value here. So I'm going to draw a dotted pink lines there to show you, like, if I were to draw a straight line going down to form a right angle triangle, that would be the y value there divided by the radius, because the radius is the hypotenuse on this right angle triangle. So that's what this would be. Using the same approach, cos theta would be x over r, because theta, well, adjacent to theta would be down there, which would be the x value, right? If that point is xy, and this would be the y value. So I'll go like that to show you. That's the x value. That's the y value. So you can see where cos theta is coming from, adjacent over hypotenuse, and the hypotenuse is r. And then our tan theta would be y over x. This is a handy or helpful way of thinking of these. And I'm going to also show you, if instead of sine, that one goes with cosecant, this would just be the flip of these two. So it would instead be r over y. Cosine goes with secant, so secant theta would be r over x. And tangent goes with cotan theta, which would be x over y. So these are some handy trig ratios to keep in mind. That kind of is review, but now we're putting it as a point on the unit circle. So instead of calling it like opposite over hypotenuse and adjacent over hypotenuse and all that stuff, we're using this point on the unit circle, and we're using, instead of the hypotenuse, we're using the radius. But it's still the same thing that we're doing, just to remind you and to keep this in perspective. Okay, so moving on, let's take a look at just another really quick thing that we can talk about. And I feel like this is also review, but review's a good thing, so don't worry about it. So if this is also review, let's say we have, I'm going to draw it here again. Remember this, all students take calculus. we use that to help determine, like out of sine, cosine, and tangent, in which quadrant are they positive. So where the trig ratios are positive. So here in quadrant 1, it would be all of them, like sine, cosine, and tangent are all going to be positive. In quadrant 2, it's only sine. Okay, but let's talk our way through this. If it's sine, then so is cosecant theta. Because remember that they go together. So I could say sine or cosecant theta. And here, if it's tan theta in quadrant 3, then it's also cotan theta. So it's actually both of these. And in quadrant 4 here, if it's cosine theta, then it's also secant theta, because those are the two that go together. If you think about what we're doing to come up with them, this makes sense. So let's maybe just take a look at one of them to help you to put this into perspective. If I were to draw a right angle here, I knew to do it this way because I know that my central angle is going to be theta. So here's where I would get my 90-degree box. And we just talked about how sine theta, let's go back to refer to this. Sine theta is y over r from up here, remember? So y over r. So now let's go back to here. Well, the y value here is positive, but the x value in this quadrant would be negative. That's why cosine isn't positive in quadrant 2. The y value is positive and the r value is always positive because of how we get to it. It's the hypotenuse. That's why sine and cosecant would be positive here. It would either be y over r or r over y, and both of those values are positive there. So we could do that for tangent and cotangent. Maybe you can try it on your own if you're unsure, unclear with this. But basically, if we were to draw it down here and had theta, we know that our y value here would be negative, so I don't want sine. But my x value here is also negative, so that's the reason tangent and cotangent end up being positive, because when I divide those two, they give me a positive answer. I just said I wasn't going to do this one for you, and then I did it anyways, and I do stuff like that all the time. So I hope that that's helpful, and I hope that you're able to make sense of how we would figure out where the trig ratios are positive on a unit circle. Okay, so let's dive into a couple of quick examples so that we can start to make sense of this. Determine cosine theta if cosecant theta equals -3 over 2 and tan theta is less than 0. Okay, we are going to work our way through this example. This is a great opportunity to apply all of the stuff we just went over. You get to see why that was helpful or how that's going to be useful to us. So here's my suggestion. Well, for starters, this would be a good place for you to hit pause, try this on your own, and then hit play when you're ready for the solution. And I'm going to dive right into the solution right away. So it doesn't ask for this, but I think almost always it's helpful to draw out what we're dealing with. Drawing and like thinking your way through it is really helpful in trying to organize and figure out what we have and what we're looking for. So this is telling me to determine cosine theta if cosecant theta is -3 over 2. Well, cosecant theta is the one that goes with sine theta. I think at the start, maybe it's helpful for us to think of it that way. And we know that sine theta is usually opposite, which is y, over hypotenuse, which is r. So then this means that cosecant theta must be r over y. So basically, r must be 3 and y must be -2. Because, I have the negative up there, but my r can't be negative. So it must be the 2 that's negative. Okay, so if that's the case, and they're negative, well, I know because of this, all students take calculus. I know that it can't be in quadrant 1 because it's negative. And sine and cosecant are positive in quadrant 2, so it can't be in quadrant 2 either. I'm deciding between quadrant 3 and quadrant 4, but then it tells me tan theta is negative. So it also can't be in quadrant 3. That's how I narrow it down to quadrant 4. So I'm going to get rid of all this stuff now that we've used it to find the information we needed. I'm going to get rid of that too, and actually get rid of that too, but I'm going to draw this because I know that it must be in here. I use that information like this and this to help me to narrow it down to which quadrant I could find this answer in. There's the first thing. So I know that theta, while I know cosecant theta is -3 over 2. So the r value must be 3. We know that that must be 3. And we already talked about this. The 2 is the y value, which it makes sense that it would be negative in this quadrant because it's below the x-axis. So that just helped me to get a mental picture of what's going on here. It's asking me to find cosine theta, which according to our new term, like we know it's adjacent over hypotenuse, but we also know adjacent is x in this case, and hypotenuse is r in this case. So shift your thinking away from Sohcahtoa, and opposite over adjacent, into x and y. So it's like I put a point there, and that would be the point xy. So in this case, it'd be positive x and negative y. So again, just getting you to wrap your head around like how we're coming up with this. Okay, so if cosine theta is x over r, okay, well that's great because I know that my r is 3, but I don't know what x is. But I can figure out what my x value is by using Pythagorean Theorem. I'm going to assume you all know how to do that, but we'll just sort of really quickly, like a squared plus b squared equals c squared, so obviously the c is 3. So 3 squared equals -2 squared plus x squared. And when we work our way through this and isolate the x, we find that x is equal to √5. I trust that you all know how to do that, so we're not going to go through it step by step. But so I would get √5 over 3 for my answer. That's what cosine theta is equal to. Okay, so I hope that that is helping you to sort of figure out what this is and what we would use this for. And let's do another example. Okay, so determine cosecant theta and secant theta if theta is an angle, I'm too lazy to write angle, is an angle in standard position whose terminal side is the graph (2x plus 5y equals 0), where x has to be less than or equal to 0. You are going to get questions like this in the workbook. I think it's helpful for us to go through one of these together, but you do have all the tools to be able to do this on your own. So I'm going to say hit pause, try this on your own, think your way through it, and then hit play again when you're ready for the solution. Okay, so my go-to thought is, okay, we're trying to figure this cosecant and secant out. That's like what we just did. But it says in standard position whose terminal side, so the terminal arm, is the graph of this thing. I would think, what is that thing? 2x plus 5y equals 0. Well, that's a linear equation. But we're used to seeing y equals mx plus b. So we can rearrange this all. And when we isolate for y here, we would get y equals, when I move this 2x over, it becomes negative 2x. And it would be over 5 though. So negative 2 over 5x. And it's just plus 0. So it would be like plus 0 at the end. But we don't need to write that. So basically, this is requiring some past knowledge. And it's also saying that we only want to graph out the negative x values of this linear equation. So when I look at the slope, I'm thinking, okay, rise over run. So it would be, it says negative 2 over 5, but I could put the negative down there, which is probably going to make more sense. So if it's plus 0, I know that my y-intercept is at 0. So then I could go up 2 and then go over 1, 2, 3, 4, 5 to the left to get my next point. And I could keep it going, but I'm just, well, oh gosh, that's not looking very good, but just pretend it's perfect. So that would be my point. So if I were to draw this out and turn it into a right angle triangle with my theta like this, it's saying determine cosecant theta. Okay, so cosecant theta, well, cosecant goes with sine. And sine is y over r, so it's going to be r over y. Just to wrap our head around this. Secant theta, so secant theta goes with cosine, and cosine would be x over r. So this must be r over x. So I'm just writing this down to wrap my head around what I'm looking for. So I need the r value, the x value, and the y value on this right angle triangle. That's what we need to figure out right now. So I already know that my x value here must be negative 5. We just talked about it. We know that if our slope was 2, then my y value here must be 2. So the only thing I need is to use Pythagorean Theorem to figure out my r. And actually, I'm being lazy. Why didn't I use my different colors? Because they work so well to help you to see where things are coming from. So to figure out that r value, this is again just us doing Pythagorean Theorem. Can I trust that you all know how to do that? When you do that, r is going to be root 29. So again, I just did 2 squared plus negative 5 squared is equal to c squared, and that ends up giving us root 29. So it's simply Pythagorean Theorem. So that means to give my answer here, that must be root 29 over the y value, which was 2. I'm going to circle that. There's my cosecant theta. And for secant theta, root 29, that's what we just found, over the x value, which was negative 5. So there's my answer for that one. Okay, so I hope that you find that useful or helpful. I'd like for you to do page 258, numbers 1 to 7, odd letters, so again, A, C, E, etc., and numbers 8 to 15, all. I know that you're doing this during the online or remote portion, so if this is way too much, you decide. For 8 to 15, you can just do every other question if you like. And that's the end of this video. I hope you found it helpful.